Hi guys, I'm going to talk you through how you do your dilutions calculations. So when additional water is added to an aqueous solution, the concentration of the solution decreases. Well, duh, that makes sense. This is because the number of moles of solute does not change while the volume does change. So we can set up the equality between the moles of the solute before the dilution and the moles of the solute after the dilution. So this is initial, this is final, and this is your calculation. So when I'm going to highlight these, I'm going to do my ones in green and my twos in pink. Remember, M stands for molarity and V stands for volume. Let's go. It says, suppose you have 100 milliliters of a 2.0 solution of hydrochloric acid. You dilute the solution by adding enough water to make the solution volume 500 milliliters. What is the new molarity? So we know that M1 times V1 equals M2 times V2. We are solving for the new molarity, is solving for M2. So M2 equals M1 times V1 divided by V2. So M2, we're going to say M1 is 2.0 molar, 2.0 molar times 100 milliliters. And that's divided by 500 milliliters. And I can leave these both as milliliters because they are both milliliters. If one was milliliters and one was liters, I would convert them both to be liters. So we have 2 times 100 divided by 500, 0.4. And I want two significant figures at least, so I'm going to say 0.40 molar. Okay. So nitric acid, HNO3, is a powerful and corrosive acid. When ordered from a chemical supply company, its molarity is 16 molar. How much of the stock solution of nitric acid needs to be used to make 8 liters of a 0.5 molar solution? Well, I told you I was doing my ones in greens and my twos in pink, and I guess I switched this time. That's okay. So let's do this. So we have, again, M1 times V1 equals M2 times V2. And we are solving for how much stock solution. So we're solving for volume. And I guess technically I can leave this as this. That's fine. So volume is going to equal this one. So M2 times V2 over M1. So it doesn't matter which ones you assign 2 to and which ones you assign 1 to, as long as you're consistent in your problem. So my molarity 2 we said was 0.5 molar times 8 liters of solution divided by 16 molar. So 0.5 times 8 divided by 16 gives me 0.25 liters. Is that how many? Yep, I want two significant figures. That works out. 0.25 liters. So that means if I was taking my 16 molar, I only need 0.25 liters of that of water. I would add that much water to it to give me this molarity. All right. So it says, if 45 milliliters of water is added to 250 milliliters of a 0.75 molar of K2SO4 solution, what will be the new molarity of the diluted solution? So I have 45 milliliters of water. Okay. They are added. This is my original one. So I have, it says I'm adding water. So that means that my V2 is going to be 250 milliliters plus 45 more milliliters. So 295 milliliters is my V2. And I'm solving for my new molarity. So M1 times V1 equals M2 times V2. All right, so I'm solving for molarity. We need to divide by volume 2. it's going to give me my M2. All right, so M2 equals, molarity 1 was 0.75 molar K2SO4. Oh, why did I draw an 8? SO4 times my volume 1, which is 250 milliliters, divided by my volume 2, which is 295 milliliters. So 0.75 times 250 divided by 295 gives me 0.63559,322. I'm looking for two significant figures, so we're going to say 0.64 molar. All right, and that is how you do your dilutions calculations. Bye.